And so the adder is going to basically let us keep pushing numbers into a data register, and each time we do that, it will add those numbers to a running sum. So let me go ahead and fire up our simulator. And if I look for help on the Pig and I look at devices, I've got a file system, an alarm clock, a bash interface, and a GPIO, which doesn't actually exist on this system. So let's go ahead and make this device that will let us add numbers together. So I'm going to open up a new window, and I'm going to go into my devices directory, and I'm just going to copy alarm.c into adder.c. And we're going to make a really simple adder device. We're just going to keep taking a value from the data register, adding it to a running sum, and presenting that sum in the data register. So the command status register is going to be very straightforward. So bit 0 set to clear sum. And then the device will clear bit 0 once the sum has been cleared. When I turn on bit 1, that's going to say read the contents of the data register and add that to the running sum. And that's all we're going to do. We're just going to have 2 bits in the command status register. We're going to need to include pigdev.h, but we're not going to need most of the rest of this. So our code is going to basically look like this. All right, that's basically our main setup for any device. So start dev is this is where we're going to be when the device begins running, so I can add things in here like initializations. Start loop to end loop, this is a loop that's going to run any time the user makes a change to the command and status register. So so let's go ahead and make this thing work. So I'm going to need an initial sum. So this will be our running sum. And then our start loop, we're going to want to know, did we get a CSR change? So if the person changed the data value, we're not going to do anything. So if we got a CSR, if we didn't get a CSR change, we're just going to go ahead and say continue. Otherwise, did the person request that we clear the sum? So let's get the CSR register, and let's see if bit 0 is set. So if CSR and 1, then we want to clear the sum. So we'll say sum equals 0 and then put data 0. So we'll clear the value in the data register also. So we'll clear bit 0 of the CSR register. We'll actually clear the whole CSR register, so the user knows that we're done, and then we'll just continue. So that's our processing of bit 0. If bit 1 was set, then we want to add what's in the data register to the sum. So we'll say get the data register value, add that to the sum, and then let's put that into the data register so the user can see the new sum. And then we'll go ahead and clear CSR1 as well as 0, so the user knows we're done, and we'll say continue. Otherwise, we're basically done, so we'll just fall through to the bottom of the loop, and then there's the bottom of the device. So that should be the entire adder device. So let's see if that compiles. So we'll compile adder.c along with pigdev.o, and we need a different macro. So let's look at what we've got here. CSR change is how we tell if the CSR register changed. So if CSR change, recompile that. That all looks good to go. So next thing we have to do is go into our device list file. And let's put our adder in here. I don't know, let's put it in slot 10. So there's an adder at slot 10, and so let's see if we can interact with this device. Alright, so I glitched out here. When I put this test in here, I said if CSR change. I wanted to say if it's not a CSR change, if it's a data change, let's continue. I probably should have just said if data change. But let's recompile that. And now I am going to have to reset the device. So I'll reset pig, and then let's deposit into the slot register an A5. A05, and then let's put a 3 into the data register, and let's put a 2 into the command and status register, and I'm going to make sure that that actually took effect by examining the command and status register. That's a 0. So if I examine the data register, it's a 3. Now if I deposit a 2 in there again and I look at the data register, it's up to a 6. If I deposit a 2 again and I look at the data register, now it's a 14, which is 6 plus itself, right? Because there were 6 in the data register and the running sum was 6, so that's 12 decimal. So if I deposit a 1 into the data register and then I hit the command status register and say add, now if I look at the data register, instead of 14, it's got 15. It went up by 1. If I deposit a -1 into the data register, and then I deposit a 2 into CSR and I examine the data register, it subtracted 1 and went down to 14. If I deposit a 10 into the data register and then I say add that, and I examine the data register, 14 plus 10, that's 24. So this is our adder, right? And it's you know, doing effect. So if I on the pig and I look for devices, of course there's no help available on the adder, but we can go ahead and create a help file. So all I have to do is give it the same name as the device, adder, but with a help extension. And all our help lines begin with a space or a number indicating a level of hierarchy. So there's a short little blurb describing how this works. And we can add a subtopic. So for these help files, subtopics begin with level 3 because they're 3 levels down in the help hierarchy. So that's just convention. So we're going to have CSR field, just CSR 0 equals clear. And this says add this to the running sum. Oh, we should take a look at the clear option also. So there's the current data register. If I deposit a 1 into the command status register, and then I look at the data register, it's gone back to 0. So here's my help file. All I have to do is reset the device, and then if I do a help and I look at devices, now I've got an adder, which is device 10, and I can look for help on that, and there's the information that we just wrote, additional information available, CSR fields, so I can look at CSR, and there's that information. So all of this, is done without rebuilding the simulator. Most of it can be done without even restarting it, some of it without even resetting the PigBus controller. And so this is all very, rapid prototype, quick development cycle, that kind of thing. So that's just an example of how we actually create a custom device.